So let's continue with where we end last time. So let's turn to page 17 of your notes. So last time we talked about how to find the distance between a point and a line, and then we introduce a formula, right? Like absolute value of ax plus by plus c over a squared plus b squared. So we can use this formula to compute the required distance. So a is 2, b would be -1, c would be 3, x would be -1, y is 2. Okay? So just plug in the numbers. And then let me see what's the required distance. If you compare this, it would yield -1, but since it's absolute value, it means that this 1 over root 5, but you need to rationalize the denominator, so it's root 5 over 5 units. Okay, so that's the first method. Okay, and then for the second method, like the traditional method, let's take a look. So draw a diagram first. So -1, 2 maybe somewhere here, and then let's say the line is here. So we need to compute this distance. Okay, so you know this line is 2x minus y plus 3 equals 0, and then we can try to find the slope of L first, okay, which is -2 over -1, which is 2. And as you know, this line, okay, is perpendicular to L, right? Let's say this called K, okay? So let's say refer to the diagram. Okay, so the slope of BK would be -1 divided by 2, which is -1 over 2. Okay, since they're perpendicular. So we now got the slope, got the point, so we can use point-slope form. So let me see. This should be the equation of BK. Okay? And then K is the intersection for BK and L, right? So solve the simultaneous equation. So x plus 2y minus 3 equals 0, 2x minus y plus 3 equals 0. So enter 1 for 1x, and then 2, and then 3. Again, remember to move the constant term to the right. And then it would yield K is -3 over 5, and then 9 over 5. So this point is -3 over 5 and then 9 over 5. So now, by using distance formula, okay, then you can get the distance, which is also -5 over 5. But for sure, if you press the decimal places, then you'll find out actually it's the same answer as well. So if you correct your 3, dp should be 0.447 units. Okay. So like long time ago, I introduced you a method on how to compute the area. Okay, the area for some triangles, right? I teach you the LC method, but then at that time I told you I would teach you the in-syllabus method later. Okay, so what's the in-syllabus method? So let's see. So we are required to find the area of triangle with, okay, this one, ABC. Okay, so again, draw the diagram first. So 11, -3, maybe somewhere here. And then B is 278, maybe somewhere here. And then C is 79, so I guess here. Just randomly, okay? And then let's connect the 3 points. Oh, sorry. It doesn't look like triangle. I drew it too bad. Wait, let me amend some scale first. Maybe B is here, then C is 7, 9, so maybe somewhere here. Okay, so it's so hard to draw it. Okay, never mind. So annoying. Wait, I'll draw it better. Give me some time. So here B 278, and then 7, 9 is here, and then A may be somewhere here. Oh, now the diagram is better. Okay, so now we are required to find the area, right? So how to find the area? By the in-syllabus method. So we can locate a height, right? Because the most original formula is 1/2 times base times height. So this time I use AB as the height. So you will know the area is 1/2 times AB times, let's say this one, CK. So AB for sure we can compare it because we got their coordinates, so we can use the distance formula, right? But now, how can we compute the distance for CK? So you know, CK is just the distance from C to the line AB, right? So again, we simplified this problem to the distance from a point to a line, right? So how to do that? Just like what we did last time, okay, in the last question. So for sure we need to solve for coordinate of K, okay, but we need to find the equation of AB first, right? So you compute the slope of AB first. So let me see. So that will be -9, and then which means slope of CK would be 1/9, okay? And then we can also find the equation for both AB and CK. So let's find the equation for AB first. So y minus 78 over x minus 2 is equal to -9, which means y equals -9x plus 96. That's the equation for AB. And then I use the program. That's why you see I save some step, okay? And then for CK, y minus 9 over x minus 7 equals 1/9. Points-law form, right? Because we got the slope of CK and then we got the coordinate of C. Let me see. So y equals 1/9 plus 1/9x plus 74/9. That's the equation for CK. So now what we did is to again solve the simultaneous equation in order to solve for coordinates of K. So now our aim is to find K, right? So we can turn this equation into general form first. So AB, which means 9x plus y equals 26, and then let me see, negative x plus 9y equals 74. Okay, just multiplied line for both sides to the equation of CK. So after you press the calculator program, you will find that, okay, K is 395 over 41, and then 3x1 over 41. Okay, with K, then now we can solve for the distance of CK, right? So CK will be 7 minus this, and then square, plus 9 minus this, and then square, okay? So let me press calculator, which means, okay, CK is 2.6 0.6505366626 units. Okay, and then let's find the distance for AB as well. Okay, so distance for AB would be 2 minus 11 squared plus 70x minus 3 squared, and then take root. Okay, so you press your calculator, it would be 81.49x46624 units. Okay, so area is this times this divided by 2, right? So you can try it and you will find it's exactly 108 square unit, which correspond to our answer. Okay, so you can see if you use LC method, then just 3 steps. But if you use in-syllabus method, it's very troublesome. That's why I introduce you the LC method. Okay, got it. So now, let's come to the next part. So just now we talked about the distance between a point and a line, and now we would like to talk about the distance between two parallel lines. Okay, so let's see. Let's say this is the two parallel lines. Okay, and then again, we are requiring to find distance, which means perpendicular distance. So like here. Okay, so actually the steps are pretty much the same with finding the distance for a point and a line. Just add one more step, okay, before, which is to find the y-intercept for one of the line. Then actually you just compute the distance for the y-intercept to another line. Okay, what does that mean? So let me see. I take example 3 as example. Okay, so 2x minus y minus 5 equals 0, which means this line. Okay, y equals 2x minus 5. So y-intercept is here, -5. And then this one, 2x minus y plus 5 equals 0. So L2 is this one. Y equals 2x plus 5. So here's 5. So for sure, this time they gave us the y-intercept already, and then we need to find this distance, right? Okay, so can you see we are finding the distance of 0, 5 to the line y equals 2x minus 5. So it's just the same thing with what we did just now, right? Okay, so we can find it. I just use the LC method, okay? It's simpler, okay? So the distance is, and write down the formula first, which is, okay, let me see. This is 2x minus y minus 5 equals 0. So a is 2, x is 0, b is -1, y is 5, and then c is -5. And then you will got the answer. Let me see. 10 over -5, which is, you rationalize it, so 10 root 5 over 5, so it's 2 root 5 units. Okay? 即係我想講話，而家揾兩條平行線嘅距離，其實同我哋啱啱揾點到直線嘅距離一樣，只不過你要加多個 step 喺前面，即係揾其中一條線嘅 y-intercept。有冇問題 ？Okay? So let's try to do example 4. So I assumed you have finished it. Okay? So I can draw something like this. So this time you would know the slope should be -3 over 2. So maybe this line will look like this. Okay? So find the y-intercept for one of the line first. So let's say find the y-intercept for L1 first. So sub x equals 0. So 2y equals 4, y is 2. So the y-intercept for L1 is 2. Okay, so maybe let's say here 0, 2. So now we are just computing the distance from 0, 2 to this line. Okay, So again, use the formula. Okay, so this time A is 3, B is 2, C is 5, and then X is 0, Y is 2. So substitute the numbers. So it should be 9, and then let me see. It should be root 13. So this would be the answer. Okay? And then we come to an important part, which is the four centers. Okay, so we got centroid, oval center, circumcenter, and incenter. So at this moment, okay, oval center and circumcenter, like the second and the third one, okay, are the most important. Okay, incenter, you don't really need to know much at this moment, since they usually will cross topic with circle, but you have no circle. And then centroid is too easy, so usually the question would be on oval center and circumcenter, so you can put a star on it. Okay, so what's centroid? You know that centroid are the intersection, right, of median. Okay, so let's try to draw a diagram. So I draw a triangle. Okay, it's not a right angle triangle. Okay, just a random triangle. So let's say this is A, this point. Okay, so let's say the coordinate, we call it x1, y1, and then this is B, x2, y2, and then this is C, x3, y3. So a triangle for sure has three sides, right? So there are three medians. Do you know what's median? Okay, so let's see. I can draw a median from A to side BC. Okay, what is median? Which means this line will bisect BC. So this point, okay, can you see the circle point? Is the midpoint of BC, right? Okay, so I can also draw a median from point C to line AB. Again, this is the midpoint, okay? And from these two median, we can already locate the centroid. This is the centroid, okay? Remember, two median, 2 is enough, okay? Because two lines can already have an intersection, right? Two medians, then you can get the coordinate of centroid. But for sure, we can also draw the third one. We can draw the median from point B to side AC. So it's something like this, okay? So how to compute the coordinate of centroid? So centroid is easy, okay? So the coordinate of centroid will be, the x-coordinate is x1 plus x2 plus x3 over 3, and then y-coordinate is y1 plus y2 plus y3 over 3. Okay, so we can take an example. Let's see, what's the coordinate of a triangle if the vertices, okay, let's say A is 1, 2, B is 3, 4, C is 5, 6. Like imagine, what's the centroid of ABC? Okay, so you can do it yourself. Okay, so the centroid, as shown in the above formula, so it will be 1 plus 3 plus 5 over 3, 2 plus 4 plus 6 over 3, which would be, let me see, 3 and then 4. Okay, so just add the x-coordinate together and divide by 3, add the y-coordinate together, then divide by 3. Okay, but there are two more important properties of centroid. Okay, so you need to know both the properties and know how to compute it. Okay, so can you see now the triangle? Okay, the triangle is divided into 6 parts, like 1, 2, 3, 4, 5, 6. And I could tell you that actually all these 6 parts, the area are the same. So sometimes you may use these results to help you do the MC, which is faster. So the S stands for area, okay? Area. And then in Form 3, you may have learned that, like, can you see like the blue median? The blue median are divided in the ratio of 2 to 1 by the centroid. Okay, or you can say the centroid divide the median into 2 to 1. So again, this will be 2 to 1. Same for the orange one, 2 to 1. So, do you know how can it cross topic to examine? It can ask you to use the internal division of segment, the formula, right? Okay. So let's come to ortho center. Okay. So what's ortho center? So you know ortho center are the intersection of height, right? So that's why you know why it's always examined, because height means perpendicular, right? So you need to make use of the slope. Okay. So again, draw a diagram first. So again, let's say this is A, x1, y1 coordinate, and then B coordinate is x2, y2, and then C coordinate is x3, y3. So again, we can have 3 heights, right? Because triangle has 3 sides. So we can draw a height from C to AB first. Because it's height, so it must be perpendicular. And then we can draw a height from A to side BC. Again, we drilled 2 heights already, so we are already enough to locate the ortho center. So the black spot is the ortho center. Okay. So for sure, we can also draw the 3rd height. The 3rd height would be like this. So now, how to find ortho center? Okay. Just now I say, right, you have the equation of 2 heights, then you can already find the ortho center, right? Okay, so we need equation of 2 heights. Let's say equation of the orange height and then equation of the blue height. Okay, like this one and this one. Okay, but then how can we find the equation of the orange one? So let's see. So we know that the orange line passes through A, right? Okay, but we still need the slope because point slope form, right? Okay, how to get the slope for the orange one? Okay, easy. Let's see. So we got the slope of BC, right? But since you know orange line and the line BC are perpendicular, so actually we also got the slope of the orange line. You just use -1 divided by the slope of BC, right? So we got the slope of orange line, and then we also have coordinate of 8, right? So we can use point slope form to got the equation of the orange line. Got it? And then just repeat the process for the blue line. Okay, so how to get the slope of the blue line? Okay, we got the slope of AB, and you know line AB is perpendicular to the blue line, so we also actually got the slope of the blue line. Okay, and then you know the blue line passes through C, right? So again, use point slope form, then we can got equation of the blue line. So now we got the equation for 2 heights, right? Then you solve for the intersection, like doing the simultaneous equation. Then you will get the coordinate of the ortho center, which is the black part. So I know that will be very abstract, okay, by just saying like how to find it. Okay, so let's try to do a numerical example. Okay, so let's take a look here. So now imagine like A is 1, 2, and then point B is 2, 6, and then C is 3, -4. Okay, so I want to find the awful center of triangle ABC. So let's see. Again, draw the diagram first, okay? So let's see. So 1, 2 maybe somewhere here. Okay, this is 1, 2. 2, 6 maybe somewhere here. 3, -4 maybe here. Okay, so let's join the dots. Okay, so let's see. Again, then you draw the height first, okay? So this will be one of the height, right? From B to AC. So that we can find the equation of this first. So you know slope of AC is 2 minus -4 over 1 minus 3, which is, let me see. Which is -3. Which means that actually the slope of the orange line, okay, the orange line, like this one, is 1 over 3, right, because perpendicular. Okay, now we got the slope, and then we know the orange line passes through point B, so we can use Pond-Slope form, right, which would give you the equation of the orange line is y equals 1 over 3x plus 16 over 3. Okay, so now repeat the process to find one more height. Let's say I want to find a height from C to AB. So actually, you know this point is the awful center. Okay, so how to find the equation of the pink line? So for sure, again, the first step, we find the slope of AB first. So slope of AB would be 4, okay? Which means the slope of the pink line is -1 over 4. Again, you got the slope and then you know the pink line passes through C, right? So you use Pond-Slope form, which would give you the answer is y equals -1 over 4x minus 13 over 4. So that's the equation for the pink line. So you solve for the intersection. Okay, for sure you can change it to general form first. So this one would be 3x minus 3y plus 16 equals 0. Just the orange one. And then for the pink one, then -x minus 4y minus 13 equals 0. Okay, so you press the program. You would have x equals -103 over 7. Y is 3 over 7, which means the coordinate of awful center would be this one. So that's a numerical example to teach you how to find the awful center. So now, your turn, okay? So I want to find the awful center. So now, coordinate A is 1, 7. B is -6, 0. And then C is 3, 4. So try to find, again, the awful center for ABC. So work it out yourself. So I assume you have finished it. So let's try to check the answer. So I would draw the diagram first. So 1, 7 may be somewhere here. -6, 0 may be somewhere here. C may be somewhere here. Okay, so I join the dot first. Okay, and then let's try to draw the height. So this would be one of the heights, okay? And then this would be another height. For sure, you can use another height, like you can draw the one from C to line AB, that's totally fine. You will reach the same answer as well, provided you like calculate it correctly, okay? So you know, this is the oval center, like the pink one. So that's our goal, how to find the coordinate of the pink one. So maybe we can start from finding the equation of the blue line first, okay? So we can start from slope of BC. So slope of BC is 0 minus 4 over negative 6 minus 3. So that would be 4 over line, which means that the slope of the blue line, okay, will be negative 9 over 4, right? Since they're perpendicular. So now, again, you know the blue line passes through A. So Poisson slope form. So y minus 7 over x minus 1 equals negative 9 over 4. After some calculation, you would know the blue line, the equation would be line x plus 4y minus 37 equals 0. Okay, so now let's find the equation for the orange line. Okay, so we can start from slope of AC first. So slope of AC would be 7 minus 4 over 1 minus 3, which is negative 3 over 2, which means the slope of the orange line, okay, the orange line, would be 2 over 3. So point slope form, okay, the point is negative 6, 0, and then slope is 2 over 3. So y minus 0 over x plus 6 is 2 over 3, which means that 2x minus 3y plus 12 equals 0. So that's the equation for the orange line. So now you set up a simultaneous equation which would give you the coordinate of the oval center is 9 over 5 and 26 over 5. Okay? So now let's go to more questions before we talk about the circumcenter first. Okay? So you can try to work on question number 1. Okay? So pause it for yourself and then you start working on it. So I assume you have worked on it. So let's see. So L1, 3x plus 4y minus 72 equals 0. Intersect the x-axis at A. So you know A is the x-intercept, right? And then intersect the y-axis at B. So you know B is the y-intercept for L1. Okay, so we can find this first. So A is x-intercept, so we will sub y is 0. Which means A is 24, 0. And then let's find B. B is the y-intercept, okay? Which means sub x equals 0. So B is 0, 18. Okay, let's see. Then there's another straight line, okay? Called L2, 3x minus y equals A. Intersect the x-axis, okay, at C. Okay, so you may want to find C, but you found that this time the equation have a variable A. Okay, so let's see, how can we solve it? So there's one more information. L2 intersect the y-axis at B. Oh, so B is the y-intercept for L2 as well, right? So we can substitute the coordinate of B into L2, which means 3 times 0 minus 18 is A, so A will be negative 18, which means the equation for L2 is 3x minus y plus 18 equals 0. So now we could solve for C. C is the x-intercept, so sub y is 0, which means that C is negative 6, 0. Right? So now we can draw the diagram. Okay, let me see. So we know A is 24, 0, B is 0 to 18, and then C is negative 6, 0. Okay, let me erase it first. So now we can draw a diagram. So let's see, 24.0 maybe somewhere, let me see, 24.0 should be somewhere here. 0.18 somewhere here. C -6.0 maybe somewhere here. So let's try to join the dots. Okay, again, this is not a right angle triangle. Not sure if I draw it too similarly. Okay, don't confuse it. So now we need to find the equation, okay, of the oval center from C, for the equation of the altitude, okay, from C to base AB, like something like this. Okay, so again, how to find the equation of the blue line? We got the slope because you know the blue line. We got the points because you know the blue line passes through C. So we still need to find the slope of the blue line. Okay, but you know we can find the slope of the blue line from slope of AB because they are perpendicular, right? So we find the slope of AB first. So it should be -3/4, okay, which means the slope of the blue line, okay, for sure we can't write something like blue line, so you can let this point be K, which means the slope of CK, okay, would be -1 divided by -3/4, which is 4/3. So we got slope, we got point, the point is C, right? Okay, so y minus 0 over x plus 6 is 4/3. So continue with your computation. So this would be the answer for part A. Okay? And now find the coordinate of the oval center of ABC. We found the equation for one of the heights already, but we still need one more height, right? Because I told you, two heights can locate the oval center, or similarly, two medians can locate the central. So let's say we can find the equation of altitude. Altitude is just height, okay? From B to CA, which is like this. This one. Can you see the orange line? Oh, this is easy. Why? Because you can see it's a vertical line, right? What's the equation for this? Can you see actually the orange line is just the y-axis. So the equation would be x equals 0, right? So now we got the equation for two altitudes. So do a simultaneous equation. Solve this equation would give you, so 4 times 0 minus 3y plus 24 equals 0. So y is x. So we know x is 0, then y is x, which means the oval center would be 0, x. Got it? And then let's do one more question before we end the lesson today. So let's do question 3 on your own first. So let's try to draw the diagram. So this time they have gave you all the points, okay? So let me see. So -210 may be somewhere here. -4 maybe here. 16.1 maybe here. So let's try to draw a line here. Okay, let me see. I want to draw connect AB. Oh. Okay, so now let's see what happens. Okay, so P is a point on AC such that BP is the altitude of ABC, which means this is P. Altitude means 90 degrees, right? Height. 垂直㗎嘛，你高一定要 ，OK？ So find the equation passes through B and P. So easy, right? Okay, again, find the slope of AC first, right? So slope of AC would be 10 minus 1 over negative 2 minus 16. So, which is negative 1 over 2. Which means slope of BP would be 2. Because negative 1 divided by negative 1 over 2, okay? So now you use Ponson's form. You got the slope and then you know BP passes through, for sure, passes through B, right? So y plus 4 over x minus 6 is 2. So 2x minus 12 equals y plus 4. So 2x minus y minus 16 is 0. So that's the equation for BP. Okay, so now find the coordinate of P for part B. So you know P is the intersection, okay, for BP and AC, right? Okay, P 係咪 AC 同埋 BP 兩條線嘅相交點啊？ So we just solve the simultaneous equation. But for sure, we also need to find the equation of AC, right? We got the slope of AC, so just use Ponson's law form. Okay, so which means the equation for AC would be y equals negative 1 over 2x plus 9. So you may want to change it in the general form. So you multiply the whole thing by 2. So 2y is negative x plus 18. So x plus 2y minus 18 is 0. That's the equation for AC. So you solve the simultaneous equation, which would give you P is 10 and 4. So this is 10 and 4. Okay. So now find the part C. Okay, part C. Find the ratio of the area ABC, like the big triangle, to the area of BCP. Oh, so you know area, you can use the skills I taught you, right? So let's try to find the area of ABC first. So 1 over 2, and then you draw 2 lines, and then copy the coordinate, and then copy the first one more time at the end. Okay, so remember, diagonal down is plus, right? So negative 2 times negative 4, and then plus 6 times 1, which is just 6, and then plus 16 multiplied by 10, which is 1 over and 60. And then diagonal up is minus. So minus 60 and then minus 16 times negative 4, and then minus negative 2 times 1. And take absolute value. So let's press the calculator. So it will be 90 square units. Okay. So now repeat one more time. Okay, for PBC, like the BCP. Okay. So let's see. So let me draw. So let me erase this first. I don't have enough space. So area of BCP. Again, 1 over 2, and then you copy all the coordinate. So diagonal down is plus. So 10 plus times 1 plus 16 times negative 4 plus 6 times 4, which is 24. And then diagonal up is minus. So minus 64 minus 6, and then minus 10 times negative 4. So this one should be 30. Okay, square units. So you know the ratio would be 90 to 30, which is 3 to 1. Okay, so that's the LC method. But if EC method, how to do it? Okay, let's see. Okay, so I already stressed that you need to know both EC method and LC method. Okay, so you know that actually ABC and BCP, like this triangle and this triangle, they have common height, right? Common height. Because both of the triangle, their heights are BP, right? So for common height triangle, their area ratio would be the side ratio. Okay, which is just which is just AC divided by PC. Why? Okay, so let's see. What's the area of ABC? Okay, let's see, a ratio, right? So area of ABC divided by area of BCP. So how do you find the area of ABC? It should be 1/2 times AC times BP, right? 底乘高除二啫。And then for BCP, okay, the area will be 1/2 times CP times BP. So we can cross out it and you will find that actually the area ratio is just the side ratio. 即係呢個係共高嘅三角形，因為大家嘅高都係 BP， 所以面積嘅比例就會等於佢哋個邊，即係個底嘅比例，所以就係 AC 除 PC。So how to find AC? You just use distance formula, okay? So I'm lazy, I don't write the step for you, okay? So you know AC is, let me see, should be what? Something like this. And then PC would be something like this. So when you divide them, it will give you 3. Okay, so the ratio would be 3:1. Okay, so that's all for the ortho center. So it's the end of this lesson.